Hi everybody. In this video we're going to be looking at how to use the LibGSM code generator to do an MQTT publish and subscribe example. We're going to be using the Blackpool board, the STM Blackpool, which has the STM32F411 microcontroller on it and can be programmed with Arduino compiler. In conjunction with that, we're going to be using the SIMCOM A7670E GSM modem, and that is provided on the Elecrow development board. You can, however, use any microcontroller which has a C or C++ compiler, and we'll be adding support for more GSM modems with time and based on demand. So if you would like support for different modem added, for example, a U-Blocks modem, then please let us know. Currently, the MQTT module supports all SIMCOM A7600 series modems that have MQTT functionality. In this video, we'll be outputting some data on the serial monitor port from topics that we have subscribed to, and we'll also be publishing messages using a button press. Later on in the video, we'll also toggle the built-in LED that is on our development board based on any messages that are received via MQTT. The first thing that we're going to do is start a new project in the Arduino IDE. So we're going to say File, New Sketch, and that'll start a new project. You can close this old window. From here, you can then save this project. So say File, Save As, and then you can save this wherever you would like. I've made a folder on my desktop called LibGSM Demo Videos, Generate Code, and I am going to call this MQTT project. You can name this whatever you would like, but this is just a relevant name for the project we'll be doing. As stated previously, this project for ours is going to be set up on the STM Blackpool, and that setup has already been done on the Arduino IDE for us. If you would like help setting this up, there are various resources online that will show you how to set this up for your specific board, or even the Blackpool if you are using the same device as us. Now we can go back to our LibGSM code generator. The LibGSM code generator is provided with the LibGSM library in order to generate your code for you to integrate with the LibGSM library as easy as possible. The first thing that you're going to want to do here is generate a new project and go to the same directory where you saved your Arduino project. In my case, that's going to be this MQTT project, and I'm going to say select folder. Once I've done that, you'll see the directory will appear in the directory bar, and I can select C++ and keep it as Arduino project. So the Arduino project checkbox here is going to ensure that your source files are put into a folder called source. This is a requirement for the Arduino IDE. After this, we're going to select our module over here that we want to use, which is the MQTT client module for SIMCOM, and we're going to say check module dependencies. This button will ensure that all dependent modules required to use this MQTT module are included in the project, so that the library can function correctly. One thing to note with the LibGSM code generator is that it can also be used to set up all of your settings regarding your buffers that are used. This video is not going to go into detail on how to set up these buffers, but if you need to change any buffers for your requirements, depending on your MCU, or if you're going to be getting really large MQTT messages, this is where it can be done. And like I said, we're not going to be covering that in detail in this video. However, there will be a separate video or videos to cover this. For this example, the default settings will be fine. Please also take note that there is extensive documentation provided for each of these modules on the LibGSM code generator that you can go through at any time. Before continuing, I just want to note that the MQT client module is a licensed module. So if you do not own a license for this module, you will not be able to follow along with this video. But the SMS receive module is free, and there is a separate video for that as well, showing how to set up the SMS receive module so that you can get a good feeling of how to use the LibGSM library, and if you would like to get any of the other licensed modules as well. Once we've completed the setup by selecting our modules, the dependent modules, and what the project type is, we can now say generate code. Once we say generate code, there will be a message saying it was successfully generated, and in your Arduino project, you will see the files that have been added to your project. As I did state now, if you do not own the license though, you will be met with an error message instead of the code generated successfully message. Now there's just a few steps required to initialize the hardware connection between our Blackpool and our GSM modem. To do this, I'm going to generate a main.h file. So in this main.h file, I'm going to start with the setup. So in here, I'm going to, if not defined main.h, then I'm going to define main.h, and then I'm going to, at this point, already close the indef so that we do not forget to do that. Before continuing with the code, I'm just going to state that generally with the GSM modems, what you can typically expect is a power key connection, which is used to power the module on and off, a status pin, which is to indicate whether the modem is on or off, and then of course a UART connection to communicate with your GSM modem. So in the main.h file, I'm going to set that up. There's also a possibility that your modem could have a reset pin. Ours does not have a reset pin, so we're not going to be including the reset pin. You can follow these exact same steps though to define a reset pin, and inside the LibGSM code generator, if you'd like to use the reset functionality, you can enable the reset GPIO, and then we'll include a function in the GSM manager for you where you can enable the functionality for this. All right, now we're going to start with our includes in the main.h. So we're going to first include hardware serial.h that we can use the serial interfaces on our STM board, and then we're going to include the Arduino library. From there, as I said earlier, we're going to be including a button press in this example. So I want to define a way that we can measure the time that a button has been pressed. So this is going to be done as a debounce, a software debounce, so that we can press and hold a button that doesn't register at multiple presses, or even if we just press it once, that it doesn't measure as multiple presses. So I'm going to name the function millisecond since, and then I'm going to use the built-in Arduino millis to be the function we use to determine what millisecond since is. From there, what I'm going to do is the GPIO setup, and then I am going to, in this section, define the pins that we will be using for our GPIO. So that's the interface, what I just explained with our GSM power key. And I'm going to, on my board, route that to pin PB2. And then I'm going to define a pin for my GSM status. That's going to be GSM stat, and I'm going to put that on PB1. From there, I'm also going to define a pin for my button connection. For myself, on the Blackpool, there is a button that is already included on the hardware, and that is defined in this Arduino setup. When you integrate STM with Arduino, that's going to be defined as user button. So if you hover over this, you'll see if it is predefined and then what pin that is on, in my case PA0. The next thing I'm going to do is the serial setup. So by default, if we come here and we open our serial monitor will by default be on the USB serial. So we want a secondary serial to be used for when we communicate with our GSM modem. And I'm going to put that on GSM serial, and that will be serial 1 in my case. Sorry, spelling mistake there. So that's going to be GSM serial 1 in my case. Depending on what MCU you are using, these might not be exactly the same as mine, so please just update it accordingly, especially the serial. Make sure if you do not have serial 1 to connect that to the correct serial connection. I just want to take this opportunity to quickly show you our hardware setup over here. So this is our Blackpool, the STM32F411, and then on this side we have our GSM modem, which, as I said, is an Elecrow development board, which has the SIMCOM A7670E. We then have our connection between the two boards, which is our TX, RX, power, and ground that is connected to our STM32. And then on the back here, we did not have breakout pins, so we've just directly connected. We've soldered these lines on, is our status line in green and our power key in orange. You'll see at the back here is our antenna that we have connected to our board, and then on the right, we have our power connection, which is just powering our development board over here. And then on the left-hand side, this is just our serial USB connection to our laptop. The next thing we're going to do is go over to our GSM manager.cpp file, and this is where majority of the code is that gets output by the LibGSM code generator. The first thing that we're going to do here is include our main.h file that we just made. It's important while we're here to note, please, that you have to include any code that you generate or that you add to these files inside these user tags. If you do not do that and you return to LibGSM code generator and regenerate any code, then that code outside of these tags will be lost. So you can see the include main.h is still here, but the testing code is gone. The next thing you'll see is your buffers. These buffer values over here, as I touched on earlier, can be changed inside the LibGSM code generator, and your debug buffer can also be changed. If you go over to Start, Settings, then you'll see your debug output buffer here, where you can change the size of this buffer. If you're going to be outputting a large amount of debug data, then you will need to increase the size of this buffer accordingly. After this, if we scroll down, you'll see your instance variables that are used by the library, and the first function that you'll come across is your GSM system time in milliseconds. So here you're going to want to, if you're using Arduino, uncomment this line of code. If not, you're going to want to include a function that will return the present value of a 1 millisecond system timer. So please include what is relevant for you in this section. After that, we're going to come to our debug UART section, and you'll see that there is example code provided here for STM32 Cube IDE, as well as the Arduino IDE. So in our case, we're going to uncomment all of the Arduino code. If you are not using the Arduino IDE, please include the relevant code. You can see over here that this is code that interfaces with the circular buffer files that have been provided, or Arduino code. So you can refer to the Arduino documentation for what these functions are doing. And as I stated, please, if you're not using either Arduino or STM, just include the equivalent functionality to be able to use your TX and RX communication correctly. This is going to be the same then over here. I'm going to uncomment this for the debug write, and then debug write text is already uncommented. After that, we're going to go to our GSM set power key and GSM read status functions. This is going to interface with the pins that we defined in our main.h file, and that for us is going to be power key and GSM status. So please include what is relevant for you. If you did not name them the same, then please just name it accordingly to what you named in your main.h file. The next is going to be our GSM prompt, which is our RX and TX communication with our GSM modem. The same as debug, we're going to uncomment all of the Arduino code in our case, but in your case, please just add what is relevant for what you're using to achieve the same or equivalent functionality. The next is going to be our TX poll. We're going to uncomment Arduino again. The same for our GSM write, write complete, and GSM can read, as well as finally GSM read. After this, you're going to come to your GSM client event handler, and this function will be triggered whenever there's an event from your MQTT module. The first thing we're going to do over here now is uncomment these two lines, which is just variables that are being used by these cases in the switch statement, and I'm going to uncomment all of the example code. Once I've uncommented all of this example code, I will track back up and explain what is happening in each of these cases. Okay, so from here, like I said earlier, this is your event handler code that will be called anytime that there's an event triggered by the MQTT module. Whether that is a connect success, subscribe success, publish success, whatever it is, there will be messages output. And if there is a message received, there will be topic data that is output. If there's any errors or within the header or within the topic itself, then there will be error messages output to you as well. And then the payload itself, all of its data will be output. This will become more clear once I have the example up and running, and then you'll get to see the exact output, and then I can step through that with you as well and explain everything that's happening. You'll see there's a lot more cases here that you can go through. You can go through these in your own time. If you'd like to see more about these cases and get some more information about them, you can head to your documentation, and then very close to the bottom, you'll find event handler code. And the event handler code here, all of the enum events are listed, and then there's just an explanation of what they all are inside this documentation. So you're more than welcome to work through that and see what all of those events are and what information they will be outputting to you. After this, we have our initialization function. So this is initializing any variables or pointers to functions that we need for the LibGSM. So you do not need to worry about changing anything in here, but you are more than welcome to step through this if you would like. The next thing is our GSM manager poll routine, and this is going to poll any of the modules that have been included into the libgsm project that we have made. After this are convenience functions. I'm not going to go through this in detail. All of these convenience functions can be found in their respective section in the documentation, whether that is power, basic comms, etc. So I'm just going to do a quick step over. So this is to get the current power status, to set the power if you want it to be on or off, to change the duration that the power key button is pressed if you would like to change that. Basic comms is communication established. Are we registered to a network? Is the internet connection? And then here is a bunch of convenience functions used for the MQTT module. So it's going to be connect, subscribe, extended functionality for the publish and a normal publish, unsubscribe, disconnect, etc. So you can work through these and go through the documentation if you'd like to see all of the functions that are available for the MQTT module. The next thing that we're going to do after this is we're going to head over to our MQTT project file. And then from our MQTT project file, we're going to start the setup. So the first thing that I want to do here is include our main.h file that we've made. And then the next thing that I'm going to do is include our GSM manager.h file so that we can get access to the functions in our GSM manager.cpp file. After that, we're going to set up one or two other things required for our MQTT project. One of the first things that we're going to set up with that is going to be our MQTT session variable. So with that, that is going to be called GSM MQTT client simcom underscore connect session. So this is the variable type that is used to define everything that is part of the MQTT session. So I'll go into a bit more detail once I've finished writing this line of code. So this is going to be everything such as your host URL that you need, the port that you need to connect to, server type, all of that information that you need to set up your MQTT connection to a broker will be defined in this MQTT session. Again, if you require any more information regarding any of the variables that are set, you can come to the documentation. So our GSM MQTT client, the connect session, what that includes. So that will be the client ID, URL, port, server type, etc. You can see all of that is. If you ever need more information, then just go through the documentation for that information. I just see over here now that I have made a spelling mistake, so that is client. The next thing that we're going to do from over there is we're going to set up everything we need to define this session. So I know that I want to subscribe, so I'm going to set up a subscribe topic so that once I start my project, I can immediately tell my device to subscribe to a certain topic. You don't have to define this immediately if you want to change the topics depending on certain events, and you don't have to make one topic to connect to, but just for this example, it's just going to be one topic, and then we will connect to that once we start up in our setup routine. So I'm going to make this example, and then iTech, LibGSM, and then from there, I'm also going to change that to subscribe. Okay. From there, I just want to state that you don't need to use this exact same topic. You can change this topic. Just a note that if anybody else is using the exact same topic that you are right now and is running this at the exact same time as you, has already published messages, then if you are at the same topic on the same broker, you're going to receive any messages that anybody else is publishing as well. So please just be aware of that. The next thing that we're going to do is we're going to set up a publish message. So again, I'm just going to have a static message. I'm not going to define the size in this case, so you can type whatever you'd like here, but I'm going to do button press message from the MQTT project. Okay, so as I said, you can do whatever you'd like here. You can change this to different messages depending on what happens. In your case, I'm just going to define this as publish message just so it's a bit more clear. And then, yeah, as I stated, you can name this whatever you'd like and change this how you'd like, but I'm just going to do one message for this example. The next thing that is important is a client ID. So we're going to define that as well. The client ID, the one thing that is important to keep in mind here is that this needs to be a unique number. So if anyone else is connected to the broker with the same ID that you define here, you will not be able to connect as well. So please make this a unique number. If you do not make this unique, then if you try and connect to the broker, especially if it's the same broker and anyone else is currently running this code as well, you're going to get an error to say that you cannot connect because someone else is already connected with the same ID. So you can make this, if you're using an ESP32 or something else, you can make this a MAC address or any other unique ID that is provided with your MCU, whatever that may be. Because if you don't, and there's any overlap to one of your devices that you're trying to connect is not going to connect. The next thing that we want to do is come into our setup, and we're going to do our serial setup first. So for the serial setup, we're going to do serial.begin. This is going to be your serial debug output. So this effectively anything that comes out of the serial monitor is going to be linked to serial. And then this is optional code, but I like to include it, especially when we want to see anything that is output on the serial monitor immediately at boot up. Otherwise, the code will run so fast that you'll miss the first outputs before this actual serial setup is complete. The next line from there, I'm just going to copy and paste again here to save some time. I'm going to then do our GSM serial at the same baud rate, and I'm going to wait for that to be set up. In this case, I would include this, so in other words, not optional, because you want your serial connection between your GSM modem and your MCU to be set up before any other code runs where you're trying to communicate with your LTE modem. All right, the next thing that you want to do is then start with your GPIO setup. And we're going to start defining the pins that we need. So specifically the pin mode. So in our case, that is GSM underscore power key. And we're going to make that an output. And then I'm just going to copy and paste to save a little bit of time. Again, we want a pin mode. This time we want it for our status pin, and our status pin is in fact an input. And then the next one that we're going to do is going to be for our button that we defined. So we want our button underscore 1 in our case. We're going to want that to be an input, but we're going to put it as a pull-up. All right, you can define this accordingly to what you need for your system, but if you've been following along with the same naming and are using the Blackboard, you can use exactly the same as what I am using. The next thing that you want to do is going to be your LibGSM initialization. So for that, it's just going to be one line, and that's going to be our GSM manager init, and that's going to call the function in GSM manager that I showed you earlier. That's all auto-generated. And then after this, I just want to output a message that says we have our initialization done. So this is going to confirm that our serial is done, our pins were all set up, and our GSM library initialization was complete. So I am going to do a serial.write, and I'm just going to write startup, and I'm going to put 2 new lines just so I can separate that from anything else that is output on the terminal after this with regards to MQTT. All right, and then the next step, what we want to do is we want to set up our connection. So you can use this function that is available, and that's going to be effectively initializing your MQTT connection with the default settings. And what we're going to do, we're going to pass through our MQTT session, and we're just defining this as default settings that are provided. So this is a function that is provided with LibGSM that allows us as the default MQTT settings. This then sets up all the parameters that I showed you earlier in the LibGSM code generator to a default setting so that you don't accidentally leave something undefined. But before we move on, what we want to do is take this MQTT session, and we want to define the MQTT client ID, and you want to make that the MQTT client ID that we defined above. So this is going to be your unique ID that you put over here. So if you want to be sure, you can just copy and paste that across. You want this to be a unique ID, please. So that's going to be your MQTT client ID. Don't forget to do this step because otherwise you're going to be using the default regardless of what you typed in here. If you don't define it, then it's going to set everything to default and you'll be using the default client ID instead of the ID that you want to use. The next thing that we want to do is actually initialize the connection to the host server. So then we're going to call our GSM manager. These are then the convenience functions I was talking about earlier. MQTT client SimCom connect. And that is going to connect with this connect session that we have defined above. So again, we're going to copy and paste that in, and that's going to begin the connect process as soon as it hits this code. The next thing that we want to do then in our case is immediately once we've connected, I want to send out a subscribe message. So I'm going to make a temp character array here. Sorry, that shouldn't be commented out. Of length 64, for example. You can make this length whatever you'd like depending on what you're going to output. And I'm going to say sprintf. I'm going to write that to my temp. And then I'm just going to say subscribing to a string value. And then again, I'm going to leave 2 lines open so that I can differentiate between my code that's being output from my setup and my actual library code. And what I want to output here is the topic that I am subscribing to. So I can see what it is that I've asked my module to connect to, and then I'm going to output this to the terminal so that I know where we are in the code, and I'm going to output temp. So then this, as soon as we hit this code, you'll be output with a message saying we're trying to subscribe to the subscribe topic. So this is going to be our message, and then we actually want to do the subscribe. I'm going to call this subscribe message debug because it's actually not doing anything with MQTT module. It's just being output to the terminal for us to see. The actual subscribe process is when we call GSM manager MQTT client SimCom subscribe. From there, we're going to give a pointer to our subscribe topic, and then we can set our quality of service here. So I am going to set that to 1. So that is your QoS over there. And then the next thing that we're going to do is we're going to head into our loop routine. In our loop routine, what we want to do first is define variables that we will be using for our button press. So I'm going to make that static uint32 underscore t, and I'm going to call that u32 button 1 action last timestamp. So effectively the last time anything happened with the button. And then I'm going to make 2 different states with this button. So the first state I'm going to make static int, and I'm going to call it int button 1 state, and I'm going to make that equal to 1. So this is assuming a default of 1 is not pressed. So in my case, assume default of 1 equals not pressed. Okay, and then after that, I'm just going to copy this to save some time again. And the next variable that we're going to have is going to be our button 1 state last. The next thing we're going to do here is make an if statement, and if in this if statement we're going to use the millisecond since function that we defined in main.h. The reason for this is just to act as a debounce as well as to avoid any additional button presses that weren't meant to be when you're pressing the button or releasing the button. This also, you'll see later down in this if statement, will be implemented in such a way that you can hold in the button and will only count as 1 button press. And we're going to put a relatively large debounce on there, 500 milliseconds. Okay, after that, we're going to say that our int button 1 state, so the state of our button, sorry, I'm going to just copy and paste this across to avoid any errors or spelling mistakes. And I'm going to say that this is equivalent to digital read of our button 1. And then after that, I'm going to make another if, and that if statement is going to read if our button state does not equal our last button state, so in other words, if the state has changed, because they are set to the same year, so they should both be the default of not being pressed. So in other words, if that state changes, then I want my last state to be my current state. So that when we come back to this function again, we know what happened last time when we came in here was whatever the status was when we looked at this again. After that, I'm going to set the time that there was last a change in action. I'm going to reset that time to millis so that I have that timestamp. And then I'm going to say if the state was changed, which we know it did change over here, and we know that the button is now being pressed, because remember, if this is 0, because 1 is not pressed, means 0 is pressed, then we know now if it is not 1 that our button is being pressed. So in other words, button pressed. From there, what we want to do is set up our publish message the same way that we set up this message over here. We're going to do the same just to debug and output. File publish, so we're going to call publish message debug so that we can see what's coming out. And I'm going to say publishing, and then I actually want to know where I'm publishing this to as well. So I'm going to say publishing to, and then subscribe topic, and I'm going to then write this out to the terminal so that I know what topic I was publishing the message to. And then after that, what you want to do is actually publish the message. So I'm going to just write a comment there for that, publish, and then this is again one of the convenience functions. And I'm going to say GSM manager, MQTT client, and I want to do a simcom publish. From there, what you want to do is provide pointers again to your topic. So I want to put it to my subscribe topic, and then the message that I am actually outputting as well. So another pointer to my message, and if we scroll to the top, we can see our published message was button press message from the MQTT project, and then that is what I actually want to get published. After that, the last thing that you need to do, so this is going to be outside of the button press, we always want our polling routine to run. So I'm going to explain that now. We've got LibGSM poll. This is going to be our GSM manager poll. So this is the polling routine I spoke about in the GSM manager. So we want to put this outside of the button press because we always want this to run. We want to hit this polling routine as often as possible. You don't want any delays slowing down this polling routine. From this point now, then, the last thing that you want to do is verify your build. So you're going to verify that. And then if you followed me exactly, you're going to have an error here as well with a semicolon that was missed out. So we're going to verify again after that, and we should have no errors. All right, so once your verification is done, you'll see no errors here, and then you are ready to start with your MQTT project to publish and subscribe to different topics. For my case though, I will need to set up one more thing, and that is I need to compensate for the voltage difference between my STM Blackpill and my GSM modem. So in many cases, your GSM modem and your MCU will not be on the same voltage level. So in my case, my GSM modem is at 1.8 volts and my MCU is running at 3.3 volts. This is not normally an issue if you have a level shifter connection between the two, but I don't. So I'll need to use an ADC to read the voltage from my GSM modem so that when I'm at 1.8 volts, I can then say, okay, the status line is high and my modem is on and ready to use. Otherwise, my MCU is going to think that the modem is never on. It's just going to keep resetting it. So the first thing that I want to do here is go over to the main.h file. I'm going to copy and paste this code in. You're more than welcome to pause and add this if you need it as well. But as I said, if you have a level shifter connection between the two, this won't be required. So what this is, I'm just defining that I need an ADC interface, and then I am setting up an output. This is a simulator status output, and then an ADC status input. So my connection from my GSM modem will actually be connected. The status pin from the GSM modem will be connected to this pin. And then inside my MQTT project file over here, I am going to include some more code in terms of the pin mode setup. So I'm going to add those pins to this section. So if the ADC is required, then please initialize the ADC status input as an input and the simulated output as an output. And then in my loop routine, I'm going to add this section of code, and I'm going to do it before the button press. So the very first thing that happens is I'm going to simulate my status pin. I'll now show you this code so that you can see what I mean by simulate status pin. So if I head to the bottom, I'm going to simulate a status pin. So what that's going to do is that's going to read my ADC status input. So as I said before, my GSM modem status pin is connected to this pin. If that is greater than this value you're going to have to work out depending on your MCU. So what this is doing is it is looking out a range between 0 and 3.3 volts, and depending on the ADC, how many bits it is, however many bits is set, I know what voltage this will be equivalent to. You can find a guide on how to find values like this online. There are numerous resources how to work out the voltage to an ADC value. From there, if I am above this value, I'm going to write the simulated status output to high. If it's not, I'm going to put it to low. So effectively, the simulated status output is now my status pin. So if my status pin is on, just set the connection to my GSM stat. So that simulated status, the simulated status output is connected to this GSM status line. So as soon as this is set high, then this input will read high as well. So effectively, I've just made a fake status connection on my MCU. From here, again, we're going to verify to make sure we didn't make any mistakes in that code. And then you'll see, again, no errors. And from this point, we can go ahead and flash the code onto our board. So from this point, what I'm going to do is put my black pill into boot mode, and I'm just going to move the output terminal to the left, and I'm going to flash it with code. Once you're done flashing your board with code, you can come over to the serial monitor and you'll see your startup message that we put into our setup code over here. So that's startup, then our message subscribing to, and then the topic we subscribe to, and you'll see that we have successfully connected to an MQTT host server and successfully subscribed to the MQTT topic. So those two messages have come from the event handler. As I explained before, if there's any events from the MQTT module, it will be output according to this case statement, or to this switch statement, should I say. And you'll see successfully connected when we have connected successfully, and when we have subscribed successfully, then this message will be output as it's shown here in the serial monitor. So from this point now, if you have a preferred connection tool that you like to use for MQTT, I like to use MQTTX to set up connections with the host server, and I'm going to use that to demonstrate the button press publish now. So if I press the button on my STM black pill now, you'll see some information come out here, which I'll step through shortly, but you'll also see button press message from the MQTT project. And you'll see exactly the same if you pressed your button at the same time as me to the topic that we have defined. Then if I come to the left here to show in the library, so this was our successfully connected messages that we had. And then we have a message here say publishing to the topic. That's the code that we set up over here saying publishing to and then our topic. And then after that, you'll see the information will be output according to this switch statement. So you'll see the topic length total and topic segment length. So the reason there's a total length and a segment length is because if your topic is longer than any of the buffers that you have defined, then this will be broken into segments. But also, depending on the GSM modem that you have, it is possible that these topics and the payloads themselves are limited to certain lengths. And in that case, it will be put out in multiple topics segments, and then we will break them up in those segments accordingly. So in this case, we can see the total length and segment length is exactly the same. So then we know that there will only be one segment that will be output. In this case, it is the topic that we have published the message to, or the topic that the message was received on in this case. And then the same is true here for the payload. It will be broken up into segments based on buffer or the GSM modem you are using if it is required. Again, the total and segment length is the same, and we can see the payload segment that was received stated button press message from the MQTT project. It'll then say end of the MQTT message was detected, and then this message successfully published to MQTT topic is any message that you get after you've successfully published. So if we were not subscribed to the same topic that we published to, we would not see the actual information that we got here. We would only see the message successfully published to MQTT topic. If we now wanted to send a message from something else to our unit running the LibGSM library, for example, test, then we could send that through, and you will see over here, test is sent. We've also received test because we subscribed to the same topic we published to. But on this side again, you'll see that you got a topic length, which is the same topic as last time, but this time we received the test message. Then at that point, we are finished setting up the LibGSM code. And then we can send that, and we are finished setting up the LibGSM code. So at this point in the video, if this is all you wanted, then you can stop here. This is all you need to set up your LibGSM code to get started to publish and subscribe to messages. If you would like to use any extended functions or anything, please refer to the documentation for that. That being said though, at this point I would like to go a little bit deeper. As I stated earlier, I wanted to include some LED toggle code. So that's just going to be depending on what message we actually receive, we're going to make the MCU react slightly differently. If you'd like to see that code, then you can stay on this video now, otherwise I'll see you in the next video. All right, so the next thing I'm going to do now is I'm just going to clear the terminal, or the serial monitor, sorry, and I'm going to head over to my main.h code. In my main.h code, the first thing that I want to do is start defining the code that I need to integrate an LED into this example. So the first thing I'm going to do in the main.h then is just define some variables for my LED. I like to make these global variables in this case because we're going to be changing them in GSM Manager depending on the message received. But I'm also going to set up a default heartbeat LED period in my MQTT project. So I'm going to make these global variables. I'm going to make them UN32 and then just name them accordingly. This is my global U32 and this is going to be the LED off time. And then I'm just going to copy and paste that to save some time. I'm going to make this my LED on time. After that, what I want to do is just define some states for these pins. So I'm going to type this in, LED built-in on, and then define LED built-in off. I don't know why I said built-in on and built-in off. So in my case, with the hardware setup that I have, if I want my LED to turn off, I need to drive the GPIO connected to that pin low. If I then want to turn it off, I need to drive that pin connected to my built-in LED high. After we have defined these variables in the main.h, we can go over to our MQTT project file. Then in the MQTT project file, the first thing I want to do, scroll to the top here, and I'm just going to set up some code for default LED. I'm just going to call it periods, and I'm going to set this up UN32. So this is just defining the default values for the global variables that we set up in our main file. So we're going to set that to 250. This is not capital, that's lowercase, and then I'm just going to copy this to save some time, and then I'm going to make that on time. All right, after that, the next thing that you want to do is scroll down to our setup routine. We're going to come here to the GPIO setup that we did, and we're just going to define a pin mode for our built-in LED. For that, we're going to say LED built-in, and this for me is defined already with my development board. So if you've interfaced your Blackpool with Arduino IDE, as I stated at the beginning of this video, that will be already defined as PC13. If you're not using the Blackpool, please just make sure that this is already defined to a built-in LED, or if you're using an external LED, that you just define a pin in your main.h that this LED is connected to. After we've done that, the next thing that you want to do is scroll down to your loop routine. And inside our loop routine, we're going to set up a variable to keep track of the toggle timestamp for our LED. So we're going to make that static. We're going to make it a uint32_t as well. And we're going to call that u32 LED toggle timestamp. So this is just going to be a timestamp. Every time the LED toggles, we're going to record the timestamp, and we've made that static so that every time this loop runs, it does not re-initialize to 0. And then underneath our simulate status pin, we're going to start setting up the code to toggle our LED. I'm going to then copy and paste some code in here just to save a bit of time. So what is happening in this function over here is that we are setting up an if statement. So I'm just going to put some code here, some comments here for LED toggle, and then this is our check button code so that it's easy when you're scrolling through to see what is what. So for LED toggle, we're going to do a digital read of our built-in LED. If we see that our built-in LED is on and the time since the last timestamp is greater than the on time, we want it to turn off. So for example, if we start 3 and our LED is on, if from 0 to 250 milliseconds has passed, we're then going to digital write our LED built-in to be off, and we're going to recapture the timestamp. Or the other scenario is that the built-in LED is actually currently off. If the built-in LED is currently off and the time since the last toggle timestamp is greater than the off time, we're going to want to turn it on. So regardless of the case, if it's on or off, we'll just look if the period that it's on or off has passed, and then we will change. So that will start a toggle at 250 milliseconds as the default, as we've just said. And what we want to do from here is just verify this code to make sure that there's no mistakes in that code. After verification of this is complete, you can now put your board into boot mode if you're using the Blackpool. If you're using a different board, you can flash it accordingly as well. So I'm going to put mine in boot mode and then flash it with the latest code. Once this flash is complete, then you can come across to your serial monitor, and there's a good chance you're going to see error codes coming out. I will explain this now. You should also, though, if you look across to your actual hardware on the LED, you should see it blinking a heartbeat blink, doing 250 milliseconds off and 200 milliseconds on. So I'm going to explain this errors that you will be seeing on your system and explain why it is happening. So we're going to see the default startup, then we're going to see subscribing to, and then the topic we've subscribed. You're going to see a couple repeated errors before saying successfully subscribed to a topic and then receiving the same button press message as before. The reason you're receiving this button press message again is because the default publish state is to publish a message as a retained message. So anytime you resubscribe to this topic, you will get this message again. If you don't want a message to be retained, please look at the documentation for the publish extended function. So that if I come to GSM manager.cbp and I come to the bottom to the convenience functions, you will see there's an extended publish. This is the base publish, and then there's an extended one where you can turn off the retained message. Right, the reason that we're receiving these errors now is that we have reflashed our MCU. So our MCU has restarted, and once it has restarted, it has no context of the fact that our LTE or GSM modem is already running an MQTT session. So the MCU is going to start up and tell the module connect to an MQTT broker, and the module is going to be confused because it already is connected to an MQTT broker. So if we want to go through these error types, you can go into your LibGSM code generator, and then from the LibGSM code generator, if you scroll down to the event handler section again, then you'll see there is error responses here. If you go down and look for the error response, it will then define what that is. You'll see error type and error code. So we've got an error type of 2 and an error code of 19. So the error type is going to be an enum. So error type of 2, we've got a connection error. Okay, from that we can tell we're struggling to connect, and now there's an error code. So the error code is going to be a direct, whatever your modem's code is that's returning to the MCU, we're going to output that to you. In our case, as an example here, if you get an error code 19 from the Simcom 7000 series, it means client is used. So the reason we can't connect to the broker right now is because the modem's going, I'm already connected with the same client ID, I can't reconnect. The library though, however, will check after it's gone through a few errors to go, am I already connected? Once it realizes it is already connected, it's going to then initiate the next command, which is our subscribe, because on setup we subscribe, and it will then subscribe and receive the message. So this error response here is based solely on the fact that we have not restarted the session on our GSM modem, but our MCU Blackpool is not aware of that fact, so it is trying to restart that MQTT session. Just going to bring this down to the bottom again, and then if we go over to our hardware right now, as I stated earlier, you will see there is a blinking LED now. So this on our module is doing a 250 milliseconds on and 250 milliseconds off as a heartbeat, and that is for the code that we have just added. All right, after this, if you want to change that toggle rate depending on a message that was received, you'll have to scroll up to your event handler, and I'm just going to above it add a helper function. So this helper function is to just remove case sensitivity. So this function I'm going to copy and paste in, but effectively what it does is it just converts anything that is sent to this function to a lowercase equivalent. So if I sent capital ON, it would just change it to lowercase on, or if it was lowercase, it would stay lowercase. If one was uppercase, it would just change that one to lowercase. What we're going to do from that point then is we're going to scroll down in our event handler code, and we're going to scroll down to the RX payload received. So when we see our event type, message RX payload, what we want to do here below the GSM debug write is we want to include some code to read what was actually received in that payload segment. So again, I'm going to copy and paste some code in here. You're more than welcome to pause the video at this point to copy this code across to your example, but just to save some time, I'm going to copy it across. I will explain, however, what this code is doing. So the first thing that we do over here, I'm just going to align it with everything, is we're going to copy the payload segment into a string value. In this example, though, we don't want this to be string, we're just going to reuse text. So we're going to copy this into our text variable. It's already been output to the debug write, so we're not going to be overwriting anything there. After we've copied it into our text variable, we're going to lowercase it. And after it's been lowercased, we're going to compare the value to the word on. If the message is on, it'll be on for 3.5 seconds and off for half a second. And if the message is off, the LED is going to be off for 3.5 seconds and then on for 500 milliseconds. If any other message besides on or off is received, it will stay on for 2 seconds and off for 2 seconds. But I think for this example, just so that there's a stark difference between them, I'm going to use this to change it back to its default flashing routine of 250. From this point then, we can verify the code again just to make sure that we haven't made any mistakes. Apologies, in fact, you will get an error here, and I believe that's because in main.h, we did not define these with capital letters on the camel case. So I'm just going to change that so that that is camel cased, and then come back to this file and re-verify that. After that, the verification should be complete. So what we can do is put our unit into boot mode again, and then after our unit is in boot mode, we can flash it. Once you flash it with new code, you're going to see the same thing I spoke about earlier again, with these errors being put out until the library realizes that it is already connected, and then it's going to carry on as normal. At this point, I'm just going to clear this terminal so that we have an empty terminal to work with, and just show you if you want to clear the retained message, you can connect to your unit here and you'll see this retained message will come through as well. If you want to, you can put retained on here and send a blank message. A blank message then you'll still receive, but the next time you reconnect, it won't have that retained message. So if I connect again now, you'll see that there is no retained message over here. At this point now, what I want to show is if I send on to this topic, how the flashing routine will change on our MCU. So we'll see we get on. And if I go through to my hardware now, you'll see that the LED now stays on for 3.5 seconds, and then it goes off for half a second and back on for 3.5 seconds. And then after that, if you want to see the off criteria, you can send the message off as well. And then once you send off and you receive off and you go over to your hardware, it'll have inverted, so it'll be off for 3.5 seconds and on for half a second. And then after that, if you send anything else, for example, LibGSM is great, then that is anything else. So then that, if you go back over to your hardware, you'll see on your hardware that the flashing routine has gone back to, 250 milliseconds on and 250 milliseconds off again, as the default flashing routine was. All right, at that point, we've covered everything that we wanted to for this video. If there's any questions, please let us know in the comments. If there's any other modules that you need made for any other MQTT modems that you have, then please let us know. There is a method to request new modules on the LibGSM code generator over here, or you can leave questions down or requests down in the comments. Thanks very much.